the shape of a figure eight. That is just, it just doesn't happen. Alright? There is a very rare situation with an overhanging cliff. I don't know the age of you guys, you're probably only babies when this movie came out, called Cliffhanger, with Sylvester Stallone, and he's holding on to the side of a cliff and it's cantilevering out like that. But when a cliff sort of cantilevers out like that, the contours are rather strange because they come back up here and this is higher than over here. So you have contours underneath each other. So in that case, you can have that situation. But in most cases, no. 99% of the time, contours do not cross over. If it's a uniform contour, that means it's very equal in space, which means that the land is sloping at a very even slope. And that's what design contours are. Design contours are a very even slope. If you see them on a survey plan, then you immediately say to yourself, that looks like that was designed by somebody a few years ago, because that's a very even man-made slope. All right? If you were to look at a contour of, say, a ski field, you'll find in Europe and around the world that often, without the snow on there, the slopes are very evenly designed because they've been man-made. Okay, so contours that look a bit like this. Now your first thoughts are that that's from a mountain, right? If I do a side-on view, probably looks a bit like that, right? That's my first thoughts when I was studying civil engineering. Definitely a mountain, right? But if you've ever been up Mount Eden and you've gone and had a look at the volcano, it goes like that, right? So what's to mean that this bit here is not a depression as opposed to a summit? Nothing. So when you see that sort of thing happening, go in and have a look at the labels on the contours. See if you can figure out whether it's going down like that or whether it's going up like that. Okay? That's really important. And I always do that if I see that sort of thing hanging around on a drawing because it makes a big difference to your quantities. Consequently, if you see this sort of thing happening, the first thing I'm thinking of is that it is a mountain range and we're going along the ridges of a mountain. Right? But in actual fact, it could also be a valley between the mountains. We'll have exactly the same shape as that. A valley being between mountains and a ridge being a mountain coming up to a peak. And just to complicate things a little bit more, if it goes across at right angles like that, that is indicating, what's that indicating?
A river?
You got?
A river?
Yeah, could be a river, but it's more likely because it's very consistent. Rivers tend to be sort of like this, don't they?
Yeah. So a road?
Road's the correct answer, which is also the correct answer to that is you need to email me before midnight tonight if you want to get yourself an extra half a mark of assignment. If I don't get an email, you don't get the half mark. He's dead right, okay? Of course, if you don't want it, you can give it to someone else.
I'll take it.
You take it. When you see that sort of thing happening, it means it's a road going downhill, but it could also be a road going uphill. And that's what the contours do. They come in like this, almost like, looks like a creature, doesn't it? Stickers here for something. They come in on an angle. In the past, I have done roads as a exercise for you guys to do as an assignment. I haven't done one for a long time. I could if I wanted, but it's part of the curriculum. But I tend to just let students know that that's what's going on, okay? When it comes to doing the minor contours, they all sort of come in on a strange angle to the road, depending on the steepness. It's really odd, which is quite different to a platform. Now, there are basically three methods of calculation. The last one we don't do manually anymore, but I need to point it out because it explains quite a bit in terms of one of the options for you. The first one is estimation. So, a good way of showing estimation is you have a contour up here, a level here which is 100. You have another level over here which is 103.2. Okay, you draw a line between the two visually in your brain, and you say the 102 contour is probably about there, and then you start drawing the contour through. Now, if I got out my calculator, I might find that it's actually there and not there. And if you try that in your assignment, you could get 1 mark. I've heard of students getting 1 mark by estimating. You might get half a mark or no mark, depending on how good you are at estimating. But I can tell you one thing, it's only going to take you about 10 or 15 minutes to finish all the contours. So that also appeals to some people. One student did every second contour by calculation and every other contour by estimation, because it fell in the middle of the, and they got 1.5 marks because it was very accurate in most places. So the estimation method, we will do a little class exercise on estimation at the very end of me talking for part 1 of this class. And just to give you a bit of a go at it, to see if that's what you want to do. Estimation is used on site a lot. We don't usually use it in the office. Normally in the office we have a program like AutoCAD. We have 12D modelling as well. Normally the file comes in 3D, and normally we can get a pretty much better estimate of the contours. But on site, you're given plans and you're told to build it. And often it's not digital, it's just a paper copy. And sometimes the contours aren't on it, and you have to just, you might only have 15 minutes and the truck's arriving at Carrington Road. Right, and you've got to put the contours on and very quickly work out how much earthworks you've got there to get rid of by truck. Because you don't want 85 of them lining up, but you do want enough there to do the job, right? So that method will get you within a truck or two, no worries. And it's quick, right? The method I'm looking for you to do to get your full 2 marks is not quick, and there's 2 ways you can do it. One way you can do it is the bottom way here, the graphical way, or as I like to call it, the node way. Remember in the end of semester 1, we had a shrub or a bush or something like that, and you guys had to put, I don't know, maybe 7 or 8 shrubs between, and you used something called a node. So you type divide, and you got a little node here, and then you move the shrub to each node, and I says I want you to leave it on the drawing so I can see it. Okay, what if I was to put nodes between here and here? Well, how many would I put? I would put 32 of them. So I divide it by 32, and you get all these nodes coming in. Right? How many would I count from here to get to that point? 102 to 103.1, 12. Right? So I count 12, and I put a little circle there because I know that that's where my contour, and it's very accurate. So if you had 3, 4 points, you do your triangles, you then work out the difference in level, dum, 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 another difference in level, another difference in level, and then you counted your nodes and you put a circle where the contour lines came through, then you can start drawing your contours in the right location, right? Using nodes. It will take a while, and I'm not going to hold back. That's going to take you a bit of time. You can't copy your friends because everybody's going to have different triangulation. Well, it would be, the odds is probably better of winning lotto than having the same triangles that you've chosen. For example, if that was a point up there, that's one way that the student could have done it. Another way that the student could have done it, that's probably not quite so good because it's square. If that was over to the side, maybe another one up here, the student may have done their configuration slightly different. They might have gone from here to here, forming a big triangle there, and then from there to there, and then they might have done the little triangle on the corner. So there's no right or wrong way how you do your triangles. That's why everyone will be just a little bit different than everybody else. And that's why you need to keep the nodes and the triangles on your drawing and freeze them. No triangles, no nodes, you're not going to get 2 marks. Okay? So that's an important thing to remember. So this method here, between A and B, is actually a method I used to use way back. I came in right at the end of manual drawing. So I'm an old enough dinosaur to remember that. But it was right at the end and people were changing to AutoCAD. And I decided to jump and a lot of the rest of them didn't. 3 or 4 years later they were driving taxis and that was it. There's no other jobs for them because they've been made themselves redundant from the design world basically. The minute the computer age came in, that's what happened. We used to get a rubber band and mark very even spaces on it, and then we would stretch it between 2 points on the drawing board, and of course the rubber band stretched, the spaces stretched, and we would count the spaces and mark where the contour was. Quite a clever way of doing it for a manual. Manually you could do it very fast as well. Remember that if you end up on site, having to calculate that quickly. You don't have nodes, do you, on site? So you can use a rubber band. So the nodes and the rubber band are very, very similar. They call that a graphical method of doing it. And lastly, there's the calculation method. I'll come back to that, okay? Before I finish this lecture, I'll show you the mathematics behind the calculation method. Now, there are a number of students here that are very, very good at maths. I realise that. And the minute that I give you a calculation method, you're probably going to say, nah, that's me. I'm in, and spend quite a lot of time doing it, but you know you'll get it perfect. That's fine. I'm not going to say which way. But you will need to mark each point where you've calculated with the contour process, okay? In AutoCAD, so that I know you've done the calculation. You can't just show me a file that doesn't have any nodes and expect me to think you've calculated it, right? What I do when I'm marking is I turn on your triangles, I turn on your nodes, I'll count them to see you've done it right, and I'll do some random checks around the drawing, and then that'll be it, okay? I don't have the time to check like hundreds of them, but if I find one wrong, it'll probably be you'll probably lose half a mark pretty quickly. Now, just because you do all this hard work, do not make the fatal error of doing this with your contours. So that's what the contour, you've changed the text type and it's come out like that. What's wrong with that?
Not space anymore.
There's a big space here. It looks really weird. And it's not the way we do it. We bring that line in to meet it. Right? And worse still, students don't even put a line there at all. And I have to go all around the drawing to try and find way over here and back over here, and oh hello, they put a label over here, and it's wrong. So you're better off putting labels so you don't like 25.0, 24.8, whatever your labels are. If they're in a row, it makes it really easy for you to check that you've done it right. Whereas if you put one over here and one here, surveyors are basically told to do that on their 12B modelling programs. And if you put them all in a row, you can follow them around a lot easier to where they go. And you can check that you've done it right, you haven't missed one out. So you need the labels on, you need them rotated. This is not a label. You know that from semester 1. Needs to be a break in it and all the rest. Right break and all that. So a lot of students do all the calculations and they don't bother getting that all tidied up. So they end up getting 1.5 in the column, or maybe 1 after all that hard work. So the things that I mark students down for, the negative marks, are things that don't take much time to get right. The difference between a drawing that's right and wrong is usually only about 2 or 3 minutes. But in my mind, it's the difference between a drawing you're putting on the fridge and a drawing, and showing your grandmother, of course, and a drawing that you're proud of to take to a job interview. And as I said, it only takes a couple more minutes to get it spot on. So I've got a couple